Hello, good day viewers. Here is another Olympiad Mathematics question. I believe this question can be solved in less than a minute, but it is going to take us longer than that, as I am going to explain every single step I write in order to carry all viewers along. This is a trigonometric problem. We are given that if cotangent of alpha is equal to 1, where our angle is between pi to 3 pi over 2, that is in the third quadrant. And also secant beta is equal to negative 5 divided by 3, where the angle beta is between pi over 2 to pi, that is in the second quadrant. We are asked to evaluate tan of alpha plus beta. The first thing I want us to do here is to simplify this. This is just a double angle for tan, right? So whenever you're given tan of alpha plus beta, you can always simplify it as tan of the first angle, which is alpha, plus tan of the second angle, which is beta, divide by 1 minus tan of the first angle, alpha, multiplied by tan of the second angle, beta. So this is what we need first. Then we are going to express cotangent of alpha in terms of tan of alpha, right, in order to substitute it here. Then also express secant beta in terms of tan beta, just to substitute it here. But we have to consider these conditions. Let's start with cotangent of alpha. Cotangent of alpha, it is given as 1. But you should know that cotangent of alpha is just the reciprocal of tangent alpha. So if you want to find tangent of alpha, you take the reciprocal of cotangent of alpha. But cotangent of alpha is 1, so this is the same thing as 1 divided by 1. Therefore, tangent of alpha is equal to 1. But let us check that condition. It stated that alpha is between pi to 3 pi over 2, which is in the third quadrant. Remember, from our unit cycle, tangent is positive in the third quadrant. So we are going to leave it positive 1, right? Then we take secant beta, which is given as negative 5 divided by 3. Secant beta is given as negative 5 divided by 3. How can we express secant beta in terms of tan beta? Remember this famous identity: if you have sine squared beta plus cosine squared beta, this will always give us 1. And we know that if we divide sine by cosine, we are going to obtain tangent. And if we divide 1 by cosine, we are going to obtain secant. So now let us divide each of these 3 terms by cosine squared beta. So we have sine squared beta divided by cosine squared beta plus cosine squared beta divided by cosine squared beta. This is equal to 1 divided by cosine squared beta. I can write it directly, but I promise to explain every single step I write. This is the reason why I'm explaining all this. To the left hand side, sine squared beta divided by cosine squared beta is equal to tangent squared beta plus cosine squared beta divided by cosine squared beta is 1. And this is equal to secant squared beta. Since we have secant squared beta here, which is equal to tangent squared beta plus 1, let us go ahead and square both sides of this equation just to obtain secant squared beta. If you do that, you have secant squared beta equal to negative 5 squared is 25 and 3 squared is 9. So secant squared beta is equal to 25 divided by 9. Secant squared beta is equal to 25 divided by 9. But we have seen that secant squared beta is nothing but tangent squared beta plus 1. So instead of this secant squared beta, we can replace it with tangent squared beta plus 1. And this remain 25 divided by 9. Our main goal is to get tan beta. So let's make it the subject. Tan squared beta is equal to 25 divided by 9 minus 1 if you subtract 1 from both sides. Tan squared beta will be equal to 16 divided by 9. So from here we can take the square root of both sides in order to have only tan beta, which we are looking for. Tan beta is equal to plus or minus the square root of 16 divided by 9. Finally, tan beta is equal to plus or minus square root of 16 is 4 and square root of 9 is 3. So we have plus or minus 4 divided by 3. But remember, we have a condition that says that beta is in which quadrant? From pi over 2 to pi. That is from 90 to 180 in the second quadrant. In the second quadrant, only sine and its reciprocal are positive. Therefore, we are going to consider a negative result. So we say that tangent of beta is nothing but negative 4 divided by 3. So we have of tan alpha and also tan beta. Let's go ahead and substitute them back into this equation. Let me just copy that. So this is what we have. What we are going to do is to substitute. We have seen that tan alpha is 1 and tan beta is negative 4 divided by 3. So this will be equal to 1 plus negative 4 divided by 3. Then we divide. We have 1 minus tan alpha is 1 also. Then multiply by tan beta, which is negative 4 divided by 3. To the top is the same thing as saying 1 minus 4 over 3, which is 3 minus 4 divided by 3, which is negative 1 divided by 3. So to the top, we have negative 1 divided by 3. All you have to do is to take this, you multiply by this. Whatever you have, you subtract 4. 3 times 1 is 3, minus 4 is minus 1. Then you divide by the denominator, which is 3. Then you also divide by multiplying 1 by negative 4 over 3 will remain negative 4 over 3. Then negative will turn this to positive. So all we have is 1 plus 4 over 3. You take this, you multiply by this, that will give us 3. Plus 4 is 7 over 3. So this is 7 divided by 3. You can change this to negative 1 divided by 3 multiplied by 3 divided by 7. So finally, this will cancel this. All we have is negative 1 divided by 7. So we conclude that tan of alpha plus beta is nothing but negative 1 divided by 7. Can you see? It has taken us longer minute than necessary because I have explained every single step. And our result is negative 1 divided by 7. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.